This live Slooh show is brought to you by the support of Slooh members and the following sponsors. Visit slooh.com to become a member today. Well, hi, everybody. This is Slooh. I'm Bob Berman, your host for this very special show about the sun and weather. A mini ice age is coming. Maybe you've seen the headlines. Well, we're going to do something about it. Our Slooh partners are bringing us live views of the sun. And while we do that, we're going to be talking about this new idea based on real math, real science, that instead of global warming, or at least superimposed on global warming, there may be a winter coming globally because of the sun's strange activity. So that's what we're going to be looking at, exploring. And meantime, hey, look at this live view from the David Thompson Astronomical Observatory, one of our Slooh feed partners. One of the great things about Slooh is that when we're not using our own telescopes on different continents, we have feed partners from, in this case, Thunder Bay, Canada. Also, we have Matt Francis and Prescott Observatory with a fine solar telescope also standing by. Right now, however, it is raining out in Utah, which is where he's standing by. So I think we might not get that view of the sun, but no matter, we will have at least one solar view. And while we're doing this, and then we're going to go to Lucy Green, who's a solar expert. Dr. Green has been studying the sun, writing about it, lecturing about it all her life. So we're going to switch over to Britain. In fact, that's what we do here at Slooh. It's an international effort. In addition to those continents, so we have our producer standing by in central Connecticut. I'm in upstate New York in the mountains. We have global enterprise. So glad you could be here. And especially because we're exploring this odd topic. Look at what we're seeing at the moment, the difference between the sun when it's quiet. This is in 2010, when we were still undergoing the longest sunspot minimum of our lives. Instead of the normal 11-year cycle, we just had a 14-year stretched out solar cycle until cycle number 24 began, finally bringing the long-awaited sunspots. Look on the right picture, and you see that 2 years later, lots of storms erupting from the interior of the sun in this view. You know, there's a lot of different ways of viewing the sun using different wavelengths of light, from the visual to the H alpha at 65, 63 angstroms, all sorts of methods. Look at our live view, meanwhile, in the upper left. Those are clouds going by. And by examining the sun and watching them for centuries now, we've seen that this sunspot cycle does affect our planet. In fact, for a period of a whole human lifetime, 70 years, from 1645 to 1715, the sunspot cycle just stopped cold. Let's look at a graph showing how the sunspots have waxed and waned throughout our lives and before our lives. Look at that. You see that? On the right side, we'll look at the more recent sunspot cycle. And finally, cycle number 24 came, and guess what? It was only half as strong as the normal sunspot cycle. So not only was there a long stretch of solar minimum of no spots, but when the cycle came back, it was very wimpy. And that's why solar experts are thinking, hey, is this the beginning of a long, extended period of solar quiescence when there were fewer storms, and maybe the beginning of a Maunder minimum? Look on the right side of this chart. From 1645 to 1715, the sunspot cycle just stopped cold. And when that happened, we had things like the English Channel freezing solid. We had snowballs being thrown around. In fact, artwork from that period of time shows people in various parts of Europe enjoying winter sports where normally you couldn't. Look at this painting. The Thames was frozen solid. The canals of Venice were frozen solid. Things that nobody had seen just during that period when the sun got weird. during the entire reign of the Sun King, by the way, Louis XIV. Isn't that strange? We had a Sun King, but no sun being active during that time. Here's our live view, again, from the David Thompson Astronomical Observatory, one of our Slooh feed partners. So this is very cool stuff. So to discuss this, we're going to go in a moment to visit with Dr. Lucy Green. But before we do that, I want to remind you that we're going to use special equipment to view two upcoming meteor showers, the Delta Aquariids, and that's coming up next Tuesday night, July 28th. We're going to start at 8 p.m. Eastern Time. And then the year's most famous meteors, the Perseid meteor shower on Wednesday night, August 12th. And we're going to keep going most of the night for that. Using super low light video equipment, we'll actually see the meteors streaking across the sky. We all know about the summer meteors. We've probably been looking for them all our lives from the time we were kids. Maybe our families took us out to visit those friends in the country, or maybe we went away to summer camp and viewed it from there. Whatever. We don't want to miss that. So 2 meteor showers coming up. We just got through the year's skimpy time for meteor showers. For reasons nobody can explain, the year is divided into a time with a lot of meteors. Even stray background meteors called sporadic meteors are uncommon from early January right through late July. And then suddenly it picks up, especially starting with the Perseid meteor shower. And then the meteors get rich and periodic and abundant. We get the Orionids and the Perseids and the Geminids in December. And so that's the rich period of meteors. We're beginning that now, and we're going to cover that with Slooh. Okay, so let's go to England, jump across the pond, and visit Dr. Lucy Green. Lucy, it's good to see you again.
Oh, can you hear me okay?
Now I hear you. I didn't hear you at first. So let me start as if this were all a rehearsal. I'll say it all over again. Lucy, it's great to see you again.
It's great to see you too.
Thank you. So, our topic now at Slooh, as we look at these live solar views, the sun looks like it's boiling, but, just so that nobody worries about it, that's, of course, our own atmosphere interposed between us and the sun, causing that turbulence. And Lucy, you know what this topic is, the latest news that maybe another Maunder minimum is on the way, and some solar researcher found a mathematical model that purports to predict future solar activity. And as you well know, some solar astronomers are saying, what with cycle number 24 being so delayed, that very deep minimum that we had, and now that we've had solar maximum and it didn't come up to snuff, fewer storms than usual, and it looks like maybe it's going to extend. Well, this person, I believe it's a woman, said that that her model shows that the sun is just getting started being weird and wimpy, and that's going to produce maybe something as deep as a ice age on Earth, just when I guess we could use it the most, just when global warming could use some kind of a break from anthropomorphic heating. The sun may come to our aid and make the weather less hot for a while in the future. Tell me about this. What do you make of that?
Well, it's interesting for me, and I tend to separate it out in my mind between the findings about what the sun's going to do and then drawing a conclusion from that about what the Earth is going to do. And so they've taken a different approach to what's been used previously to try and predict what the sun's going to do in the future. So typically you would use the sunspot numbers. So you were showing that lovely record that we have going back 400 years, and you see the cycle ebbing and flowing. And that data can be used to then look at the shapes of those cycles, how quickly they rise, how long they last for, and use that as a way to predict what's going to happen in the future. But that tends to be when you first have the spots of a new cycle. It's very hard to make predictions beyond that. So what you can do is look at longer term data sets, and some previous studies have used data going back thousands of years, in fact, and they use not direct measures of the sunspot cycle, because you can't do that before we have the telescope observations, but what we would call proxies, so signatures on the Earth that would indicate how active the sun was. And you can go back thousands of years using things like ice cores. And it's interesting because that work was showing that the sun seems to be coming out of a time of particularly high activity and a time of lots of sunspots. So it's interesting that this work that Valentina has done is looking in to show, or is finding the same results, that it looks like the sun's going to be less active in the coming cycle. She uses a different technique. She's still looking at solar data, but now looking at the magnetic fields of the sun. So sunspots are one manifestation of the sun's magnetic field, but there's all this sort of background field as well. And you're right, she creates this mathematical model, and she's then able to use that to predict what the sun's going to do in the future. So I think her findings build into what the community is generally thinking, that the sun has been particularly active during the space age. Great for us. We've seen lots of exciting phenomena in the sun's atmosphere, but we're probably coming out of that now.
Okay, and as we come out of it, I mean, as you well know, during the Maunder minimum, 1645 to 1715, here we had fewer, if any, spots, and we also had very cold weather. Colonies in Greenland and Iceland moved or perished, and weird things happened. The coldest winters ever seen in North America, all sorts of things. So you mentioned before, Lucy, that that you're more hesitant to apply these things to Earth. But I'm sure you agree that during extreme events such as the Maunder minimum, there does seem to be a correlation with earthly weather. So would you say that what folks are saying, that if the sun really is beginning a period of quiet, that this really could very well cool our planet and maybe serve as some sort of screen or a little bit of the subduing of the global warming that humans may be causing? Is this reasonable?
I really like this topic because it is really cutting edge research. So it's interesting to remember that the visible light we see coming from the sun is just one small fraction of the overall wavelength range. So it gives off a lot of visible light, but it also gives off ultraviolet, radios, X-ray waves, all across what we'd call the electromagnetic spectrum. Now, the amount by which the visible light varies during a solar cycle is actually very small, and you get more visible light coming at times of when you have lots of sunspots, which sounds a bit counterintuitive, but actually the changes in the sun at that time make it a little bit brighter. And then when there are no sunspots, it becomes a little bit dimmer, but only by a fraction of a percent. But it sort of fits with people thinking, oh, okay, well, during a Maunder minimum, the sunspots disappear, the sun gets a little bit dimmer, therefore we would have a cooling effect on the Earth. But it's not a very strong effect. What's interesting is when you look at the changes in other wavelengths over the solar cycle. So, for example, ultraviolet light, then you start to get much bigger changes between the times when there's lots of sunspots, the sun's very bright in UV comparatively, and when there are no sunspots on the sun, it dims significantly in ultraviolet light. So you imagine, during the time that you were talking about, around 2009, 2010, when we had this extended minimum, the sun dimmed significantly in ultraviolet light. And I think that's where people are thinking the link to the weather might come from. So there's been some interesting work that I know of happening both in Germany and also in the UK as well, that looks at, well, perhaps it's changes in the sun's ultraviolet light, which in turn gets absorbed by the Earth's atmosphere, which then in turn might have an effect on our weather. So they talk about things like global wind patterns. And so it's also interesting living in Britain, because our weather is heavily influenced by where the position of the jet stream is. And there seem to be these events called the blocking of the jet stream that might be related to the amount of ultraviolet light coming from the sun. So it starts to get a lot more complex. But there's also something else I wanted to say as well, because the Thames is often talked about as being this indication of a cooler climate during the Maunder minimum. But it's also interesting to remember that back in the 18 and 1700s, the Thames was a completely different river back then. So it was much wider, it flowed more slowly, It had separation of the salty water towards the sea and then the fresh water upstream. And so actually it was much easier for the Thames to freeze over. So we've got this wonderful picture here of a frost fair in 1682. And these continued up until around 1814, I think was perhaps the last one that was recorded. Because after that, the River Thames changed. So yes, the measurements show that the Earth, or that not sorry, I shouldn't talk globally, but London temperatures, or at least European temperatures, were a bit colder back then. It's also interesting that the River Thames was a very different river. So, so sort of to put that all together, I think if we were to move to a time in the coming solar cycles where we have the situation and where the sun's a lot quieter, I don't know that we would necessarily have a repeat of those frost fairs. But what we do seem to have a strong indication for is that we might have colder winters in Northern Europe. That seems to be a product of the way the jet stream moves because of these changes in the ultraviolet light. So I think there's not a feeling that the globe would go into a mini ice age, but that we might feel an effect on our regional temperature.
So there you have it. So it's not, and this is Dr. Lucy Green, who knows where from she speaks, and she's not being dismissive of these predictions, which sound dramatic, and instead. Lucy is somewhat supportive of it, so it really, really could happen. And just for before we finish, just for our geekier members who want to put actual numbers on it, tell me if I'm wrong. I seem to recall that in visible light, the solar radiance during a sunspot cycle ranges from about 1365 to 1366 watts per square meter, which is less than 1%. Maybe closer to a tenth of 1%, but in the ultraviolet, parts of the ultraviolet, it can vary by a fully 10%. Does that sound reasonable to you?
Yeah, absolutely. You're right. It's a fraction of a percent in the visible part of the spectrum, and then it really ramps up as you go through ultraviolet, and then the shorter wavelength range of ultraviolet that we would call extreme ultraviolet, and then again up into the X-rays as well.
Very cool. This is such cool stuff. And I wish we had an hour-long show because I know everybody's so excited by it. But I want to thank you so much for taking the time from your busy day to come on with us as we stare at the sun now. This is a live view of our beloved closest star, and explore this very intriguing topic that can affect all of our lives, really. So, Dr. Green, thank you again for joining us. And I look forward to
Thank
next
you.
time as well. Okay, so let's wrap this up a little bit. We're here at Slooh, looking at these live views of the sun. We have feed partners all over the world, as well as having our own observatories here at Slooh over the world, with members enjoying controlling telescopes, enjoying the views that always stream in live. This is always live, and we're looking at the moment live views from Thunder Bay, Canada. Our view from Utah was rained out. It's actually rainy there. And what we were talking to solar researcher Dr. Lucy Green about was the prediction, brand new way of looking at the sun, a mathematical model that seems to predict that in the coming decades, not only will this be counteracting global warming to an extent, but may even produce a mini ice age. Can you imagine that here on Earth? Thanks to the sun acting strangely. We've seen the sun acting weirdly before, from 1645 to 1715, a whole human lifetime of essentially no sunspots, no storms on the sun, no displays of the aurora borealis. But we may be in store for such an extended period again. And it's not an apocalyptic thing. On the contrary, it may actually be good for us. Intriguing stuff. We'll bring you the latest here at Slooh. And we're also going to be bringing you, to remind you again, the live views of the Delta Aquariid meteor shower that comes up next Tuesday night starting at 8 p.m. Special low light video type equipment, watching the sky and seeing these shooting stars as they streak away from the constellation of Aquarius. And then on August 12th, the most famous meteor shower of the year, the Perseids. And those get cranking up. We're going to start at 8 p.m. and go for a big chunk of the night. Again, with live commentary, live views of it. And that always happens at Slooh. Slooh, we always bring you whatever event is making the headlines and even some before they make headlines. In other words, visit by an asteroid that companies are intended on mining in the future. We just had the CEO and chief engineer of the foremost asteroid mining company, Planetary Resources, as an asteroid whizzed by a few days ago. And so these next events coming up will involve meteor showers. Cool stuff. Always cool stuff here. So thanks for joining us. I'm Bob Berman here, your host tonight, and we'll see you the next time something cool happens, which is never more than a few days away. So again, thank you for joining us here at slooh.com.